Hello, and welcome back to the Jungle Histology online training series. My name is Ken Longenecker, and this 10th module is designed to supplement the 9 modules you've already watched, where I showed you the methods my colleagues and I use to perform rapid reproductive analysis on coral reef fishes. For those other 9 modules, I've assumed you'll be working in an environment where you can't immediately process fresh specimens, or you don't have the ability to freeze specimens as they're collected. This module is going to show you some money and time-saving steps that you can take if you do have access to fresh or frozen specimens. Now, I want to emphasize that there's only a couple of situations under which you should use these methods modifications. The first is that you have access to fresh specimens and that you can process them within an hour or two of capture. The second is that your specimens were frozen shortly after being captured. If either of these situations apply to you, I'd like to strongly encourage you to consider using these methods modifications. They have a couple of advantages, and the first is that you need far less fixative to process your specimens. This will benefit you in a couple of ways. First, you don't have to transport as many chemicals. It'll cost you less to buy fewer chemicals. And by using fewer chemicals, you'll have a far easier time properly disposing of them. The second advantage is that you're going to greatly speed up your processing time because Gilson's fluid acts much more quickly on fresh or previously frozen tissues than it does on fixed tissues. So you'll be able to generate fecundity estimates much more quickly. It turns out that there are very few steps that are changed from the 9 modules that you've already viewed. I'll try to demonstrate that by using still frame captures from the previous 9 modules when we're simply repeating a step. The only new videos you'll see during this module are for the steps that are changed somewhat. We're going to begin with recording the date. Next, you'll measure the length of your specimen to the end of the middle caudal ray, being sure that the mouth is closed. Record that length on your data sheet. Then weigh your specimen using the smallest capacity hanging spring scale that you possibly can. Record the whole body weight of your specimen. Then prepare your 2-part specimen tag. Remove the gonads from the specimen, and judging by your naked eye, record what you think is the sex and maturity status of that specimen. In the previous 9 modules, I told you to fix that gonad at this point. And here's the first big change. Instead of fixing the gonad at this point, you're going to perform several steps on fresh gonad tissue. The first thing you'll do after taking the gonad out of the fish, and for this step it doesn't matter whether it's male or female, mature or immature, you're going to take the weight of the whole gonad. Record the weight of that whole fresh gonad. These next few steps are for fecundity counts. Now we're only going to do these next couple of steps if we think we have a mature female. Now remember, we're trying to err on the side of oversampling for fecundity counts. You're actually going to look at your histological results to determine whether you did indeed have a mature female. If at this stage you think you have a mature female, take an approximately 1 centimeter cross section through one lobe of the ovary, then weigh it. And be sure to record the weight of that cross section. You'll then take that cross section and preserve it for later fecundity analysis. You'll put it in a falcon tube, and note we've already added the Gilson's fluid and we've already included the large label with the specimen number. So take your 1 centimeter cross section, put it in the falcon tube with the Gilson's fluid, cap it off, and give it a little shake. And just as you learned in the previous modules, you'll shake those fecundity samples daily until it's time to process them. We found that it takes about 1 week until your fecundity samples are ready to be counted. This next step you're going to do no matter what type of gonad you have, male or female, mature or immature. You might have noticed we've been having a hard time cutting these subsamples from fresh tissues, so you're going to take a chunk that's larger than 8 cubic millimeters, more like 27 cubic millimeters. Also note that in the well trays above we've already added our Dietrich's fixative and the small tag with the specimen number. Take your chunk of tissue and put it into the well plate with the fixative. Wait at least 24 hours after you put that tissue sample into the fixative, and it'll be properly fixed and firmed up enough that you can trim it down to a volume of about 8 cubic millimeters. And now, beginning with dehydration in alcohol, you can continue with the histological processing steps that you learned in the previous 9 modules. This concludes the supplementary module, or Module 10. I'd like to take a moment now to thank our funders